Okay, we live in a world of Internet of Things or IoT, when each and every facet of our everyday lives are connected to the internet via small smart devices known as embedded systems. Embedded systems are everywhere, from mechanical components like automobiles, power grids, to army, navy, biomedical instruments, as well as Industry 4.0. In fact, the recent war between Armenia and Azerbaijan is the first war in human civilization that has more embedded components than human beings. Therefore, upholding their reliability and security is of utmost importance. To this end, in our lab, the Trustworthy and Intelligent Embedded Systems Lab, we develop hardware-based security solutions to embedded systems. Existing antivirus software are not sufficient for securing embedded systems, as we have seen from the recent Colonial Pipeline hack a couple of years ago. So we developed the hardware as the root of trust to secure these embedded systems. It's much more difficult to subvert a hardware compared to a software. And I'm glad to say that some of our research is being productized by Intel to detect crypto miners at this moment. Now, when I say the hardware is the root of trust, how true that is. Gone are the days of pre-globalization era when IBM used to make everything in their own in-house. Nowadays, most of the IC design houses or hardware design houses introduce a lot of third-party players in their whole design process. If you're using an iPhone, Apple doesn't manufacture your own chip. Now imagine somebody manufacturing the iPhone chip, creating a vulnerability in the iPhone chip. Now do a thought experiment. Let's imagine for a chip that is being used in the US Air Force. This can compromise our national security. So we need techniques to actually secure our next generation embedded hardware. My group is working on designing verification protocols to verify the security of embedded hardware. The third thing we are working on is functional safety. Now, modern automobiles have more electronics than mechanical components. And these electronic components are prone to failure due to latent defects, single event upset, environmental variations, etc. Now, these defects, if not detected, can cause safety violations. And this is even more exacerbated when you're using a self-driving car, which has machine learning with zero human involvement. Imagine you're on a self-driving car from here to Houston on the I-45, and suddenly, due to a misclassification, your car hits a roadblock. There's zero chance you will leave. So we defined protocols to improve the functional safety of these automobiles. The last thing we work on is quantum computing. Quantum computing has been making news recently because of their exponential speed up in performance compared to classical computers. In fact, this year's Physics Nobel Prize, all 3 scientists were quantum computer scientists. So in our lab, we develop reliable paradigms for quantum computers because quantum computing is very much prone to noise, and fidelity is a big, big issue in quantum computing. That's all, and thank you for inviting me.
Oh.